Now let's solve one last problem. No, let's solve actually one easy one and then we'll wrap up with one last one. Suppose velocity as a function of time is given as half kt square and they're asking for average velocity. What will be the average velocity if the particle is moving in a straight line? Average velocity is the displacement upon time. So displacement is dv by dt. I'm so sorry. Velocity is ds by dt, and that is given as half kt square. From here we can get displacement, expression of displacement by integrating this. Now you have to do it, you have to take jump in steps and you have to generate speed in you. Now displacement from here you can get by integrating this function. That would be kt cube by 6. Okay, so this is the displacement at any given time. Let's suppose we are looking for a time period 0 to t. Then displacement from 0 to t, you just have to keep capital T here. So displacement at time t is kt cube by 6. And then actually the average velocity, if you are looking in this time period, then average velocity is displacement upon time. So velocity average at given in the time period 0 to capital T, because that would change. As you can see, velocity for different time period will be different. If we calculate average velocity for 0 to 1 second, that will be different than 0 to 3 second or 2 to 3 second, because velocity actually is time dependent. So we'll have to fix the range first. We are looking for 0 to capital T, this period. Then for average time period from 0 to capital T, the distance covered is k t की power 3 by 6 and the time taken is capital T. So it will be kt square by 6. This will be the average velocity. Okay. We'll do one more easy one. Suppose velocity is given as this: v0 sine omega t. v0 is a constant, omega is a constant, and t is time. So velocity is dependent on time. We have expression of velocity like this. Not in this case, they are asking for average velocity, and for this you should have a little knowledge of the graph, the curve, sine curve. Sine curve is this, and I hope you should have already, either you should be knowing it from class 10 or you must have been introduced to this by now in maths, perhaps in the chapter of function. But if you, in case you don't know, then this is how the graph of sine is. This is sine theta, this is theta, this is 90 degree, which we write it as in radian pi by 2. This is pi, this is 3 pi by 2, and this is 2 pi. And after 2 pi, the same cycle continues. So whatever the value is at 2 pi, the same value will occur at 4 pi. Likewise. Okay, so it's a periodic function. You must be knowing this. Now they are asking for average velocity. Now for average velocity, as we did in the last case, average velocity is displacement upon time. So v is ds upon dt, which is given as v0 sine omega t. So from you should be able to write the expression of displacement directly by integrating this, which should be equal to minus v0 upon omega cos omega t. Let's cross check. If we differentiate this, we should get this. Differentiation of cos is minus sine, so minus minus goes plus, you get a sine, and then also differentiation of omega t, which is omega. Omega gets cancelled. So we have done it properly. Initially, when you are still in the learning phase, initially you are learning it for the first time, you should always cross check your integration. Differentiate it and see if you are getting back the same function. Okay, so this is displacement. A displacement after a time period t. See, this is displacement, and at t is equal to 0, this is the curve of sine. Let's see the curve of cos. Cos 0 is 1. If you are plotting cos theta, so when theta is 0, cos is 1. Then at 90 degree, which is pi by 2, it becomes 0. And then it becomes minus 1 at 180 degree, which is pi. And then at 270 degree, which is 3 pi by 2, it becomes 0 again. And at 2 pi, it becomes, which is 360 degree, it becomes 1 again. So this is pi by 2, pi, 3 pi by 2, and 2 pi. And this same cycle continues again and again and again and again. This same curve is repeated from here. So again it will start like it started from 1 to 0, it will again start from 1 to 0 and then minus 1 and then. So it continues. So if you're looking from one time period, the displacement, this is displacement. So at t is equal to 0, the value of cos, t is equal to 0, cos 0 is 1. So this value is minus omega naught upon omega. Now at the time period, if you're looking for one complete time period, again the value of cos is going to be 1. So this thing is again going to be 1 and displacement is again going to be the same. So net displacement in one time period will be 0. So the average velocity, if you are looking at, then average velocity will be equal to 0. V average is equal to 0 by the argument that the displacement in the time period will be 0 because cos is a periodic function. It repeats its value in the time period. So if we are looking in one time period, then the value will be repeated and there will be no displacement at all. It comes back to the same position. So there is no displacement, then there is no average velocity. I'll add few more problems using trigonometric function in the exercise. So when you're doing the exercise in kinematics, you'll have more practice. So I'm winding this section of integration and moreover this differential and integration that we have studied so far after this problem, and then we will enter into the physics that we have been waiting for.